Hello and welcome back. I'm going to be talking about Unit 3 now. So, Unit 3, once we wrap this up, you should be, like I said, doing derivatives off the top of your head. You should be proficient, all right? This part should not trip you up, okay? If this is what you struggle with, then you really need to practice because the problems should have this be in your algebra. This should be the easy part of the problems. So, topic 3.1 discusses the chain rule. So it just says that the derivative of a function f of g of x is f prime of g of x times g prime of x. Okay, well, what does that really mean? How do I digest it? All it's saying is take the derivative of the outside, ignoring the inside. That's step one. So let's say we have the following. To the power of 3x minus 2. Take the derivative of the outside function, right? What's the outside function? What's the exponential, right? It's the very outermost final function, right? That you compose. If you plug in an input here, it's going to have to be first multiplied by 3, then subtracted by 2, and finally e raised to the power of it. So that's the outer function. And we know the derivative of that is e times 3 to the 3x minus 2, right? E to the x differentiated e to the x. And the second step, multiply by the derivative of the inside. And in this case, it's 3. So remember, take the derivative of the outside times the derivative of the inside. The derivative of the outside, which is just sine, and we ignore this, right? Maybe make a little block, and it's just cosine of the block times the derivative of the block, which is 2x plus 1. And if we have multiple compositions, well, we could still do this anyways. The outermost function is sine, so the derivative of that is cosine times, the inside, right? Can't forget that. Um, Times, right? What's the derivative of the inside? Well, we're going to use another chain rule, right? So multiply by the derivative of the outermost function, which is what? Negative sine of the square root of x minus 1 over x plus 1, right? Times the derivative of the innermost function, which is again a composition. So we're going to use the chain rule again, right? The derivative of the square root of x, you could use power rule, or you could just memorize it's 1 over 2 times the square root of that, times the final inside, the derivative of the inside, which is just a quotient rule. So this is a pretty complicated derivative, but you should be able to do this with ease. Using quotient rule, the derivative of the numerator is 1 times the denominator minus the numerator times the derivative of the denominator, and all of that over x plus 1 squared. You can simplify it, but the important part is getting the derivative down. Topic 3.2 relies on the chain rule heavily, so you should know it. Implicit differentiation. Now, let's say we wanted to find the slope of a tangent line to an algebraic curve, okay? There's a lot of curves algebraically that aren't functions, right? But nonetheless, we can still find the derivative by at a point, right, by differentiating what we know as implicitly. So how are we going to do it? We're going to differentiate both sides using the chain rule, okay? So let's say we had x squared plus y squared equals 4 at 1 comma root 3. You should know that's not a unit circle, a circle with radius 2 centered at the origin, but that's fine. So differentiating both sides using chain rule, we get the derivative of x squared plus y squared is equal to the derivative of 4. The derivative of x squared in respect to x is 2x. And here is where you have to remember chain rule. Now, this is where the alternative notation of chain rule, which I'm not going to include to not confuse, but really taking the derivative of y squared, for example, is just saying using chain rule 2y times dy over dx, right? Or you could write y prime, it doesn't really matter. And now we just solve for dy dx. And when we solve algebraically, we're going to get a function of x and y, which is why you need the point, not just the x coordinate, because it's not a function. And here's a little note to help you better know chain rule. The derivative of 3y, right, in respect to x, always remember the variable you're differentiating in respect to, is 3y prime. The derivative of y squared, no, prime, is just 2y times y prime. Never forget the y prime. That will trip you up, and without it, you're not going to be able to solve the problem, frankly. And sine of 4y prime is cosine of 4y times the derivative of 4y we said is 4y prime. And finally, we just plug in x comma y, but that's the easy part, and that helps us find the slope of the tangent line. Remember, we talked about that in Unit 2? In this case, though, we have to first differentiate implicitly and plug in the x and the y. Topic 3.3 talks about differentiating inverse functions. So here we have the key thing you need to memorize, but I'm going to show you kind of graphically why this is true. So let's say we have y equals x cubed and x equals y cubed. These functions are inverses, okay? And algebraically, or sorry, geometrically, it's the result of reflecting 1 over the line y equals x, okay? And in fact, if we want to take the slope of the tangent line, notice the tangent line is also going to be reflected over the line y equals x. So what we're saying is that if we're just flipping the functions, you just have to memorize that the functions inverses, the derivatives are just going to be reciprocals, right? If it's 1/2, the other one's going to be 2, and so on and so forth. The precise formula is that the derivative of an inverse function at x, evaluated x, is 1 over the derivative of your original function f, evaluated at the inverse of x. And I think this example helps you digest it. Let f and g be inverse functions of one another. Find g prime of 2 if g of 2 is 4 and f prime of 4 is 1/3. Okay, well, how do we find that? Um, okay, well, g prime of 2, we know f and g are inverse functions, so let's try writing 1 over f prime of f inverse, which is g, by the way, we said it, of what is our x? Well, our x is 2. That's 1 over f prime of g of 2, we said is 4. Oh, we have f prime of 4. So it's 3. So remember this, okay? Take the reciprocal, okay? Um, and once you have that, it's not really going to use the notation. You're just going to say f and g are inverse functions. But once you have that, you'll be able to nail it as like every single time. Now, if f is x cubed, find f inverse. This is a problem that they might ask that you need to know. Okay, so first put y equals x cubed, then flip x and y, and solve for y. And now once you've solved it as a function, just express y as f inverse of x. In this case, it's the cubed root of x, okay? And remember that geometric interpretation and know how to evaluate the derivative of an inverse function. 3.4 is differentiating inverse trigonometric functions. And here is a long list that you don't actually need to memorize, but if you do want that 5, I would highly recommend you do memorize this, okay? It is not necessarily the most tested and it won't make or break your score, but it is the difference between the top scoring students. So for u, which is just a function of x, we're going to start expressing that because it's easier that way. The derivative of arcsine is u prime over the square root of 1 minus u squared. Our cosine is negative u prime over 1 minus u squared, and so on and so forth. So memorize this table, okay? If I had to say what they would ask the most, I couldn't tell you honestly, because it doesn't show up as much as you'd think, but just memorize it, just add it to your list of things to memorize. Because they can show up, right? So for example, find f prime of x is fx is x squared plus cosine inverse, or like I said, they might give you arc cosine. Don't worry, they'll tell you in the exam that do the exact same thing. So f prime of x, right? We know hopefully our rules. That's 2x plus, and what is, well, the derivative of cosine? Well, it's negative. U is x plus 1, so the derivative of that is 1 over the square root of 1 minus u squared, right? And notice, hopefully, I don't know if this becomes clear or not, but for arcsine and arccosine, they just have like negative of 1. And for arcsecant and arccosecant, again, negative of one another. And the same thing for arctangent and arcotangent, right? So you only need to memorize 3 in reality. So topic 3.5 here is just selecting procedures for calculating derivatives, right? Here, you should just be able to start cranking out any derivative problem that they give you, okay? You need to be proficient in this, okay? I can't emphasize this enough. So the derivative of sine inverse of, okay, x cubed, right? Well, remember, if we x cubed is our u, we're going to write u prime, which is 3x squared, over the square root of 1 minus u squared, which is 3 cubed. Remember, this is just an application of the chain rule, but you can just memorize it using u prime if that's easier. And plus, right, plus 2 over, and I'm going to say this is 2 times 1 over 2 root x. You can just do this. And again, if it helps you, you could just write using power rule, express it. As long as you don't make mistakes, that's perfectly fine. I just memorized specifically for the square root of x, right? But for radicals, express it as a rational exponent. Topic 3.6 is calculating higher order derivatives, okay? Second, third, fourth, fifth, I don't care. Now, you're not going to be asked to calculate nth order derivatives, like calculate the generalized Leibniz formula, but you do need to know that for second derivatives, right, or third derivatives, you do need to know f prime prime of x is the derivative of f prime of x, okay? And it can be noted in this way, f prime prime, or d squared dx. As well, you might see it f to the power of n of x. Don't get confused necessarily. Um, Also, it will have the parentheses, right? Don't get confused with the notation. They'll rarely ever ask you past third derivative, so you don't have to worry. But you should know this notation and saying that taking the nth order derivative is just the same thing as differentiating n times. If they ever say f is twice differentiable, that means that the second derivative, its domain is all real numbers, or it's all real numbers in the context of the problem. For example, find h prime prime of t, and h prime of t is just what? Okay, h prime prime of t, right? Well, h prime prime of t is h prime of t differentiated. And let's say we had the function, um, I don't know, cosine of 2x. Well, then h prime prime of t, which is h prime of prime. So with the derivative of cosine, negative sine, correct, multiplied by the derivative of the inside 2 prime, which is negative 2 cosine 2x times 2 again. And of course, g of x, find the derivative and find the second derivative. Always go in order, right? So this is that multiplied by the derivative of the inside, which is 6x squared minus 9. All right, and if we want to take the second derivative now, we're going to use product rule. Uh, So we're going to take the derivative of the left, multiply it by the right, okay, and add the left times the derivative of the right, well, of x. So that's how to calculate higher order derivatives, and that is all the topics in Unit 3. By the end of this unit, like I said previously many times, if someone gives you any known function, obviously, you should be able to calculate its derivative with ease. No matter how complicated it is, you should be able to verbally, not just written. I mean, that's okay. But if you really want to be proficient, verbally say the derivative out loud in an instant, okay? If you could get to that point, you are fine for the first 2 units. Assuming also you do the other stuff as well, but you should be fine calculating derivatives, okay? And as well, you should know your derivative rules because it comes up in anti-differentiation. So practice, 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 and with no luck, you'll be doing great. So good luck.